nodal analysis based problems. Okay, so we have discussed one by one. If anyone faced doubt corresponding to, okay, in previous lecture, then tell me, I will discuss again. Okay, so now corresponding to question, first of all, read the question. Our motto determine find out I naught with the help of using nodal analysis. So first of all, everyone try, then I will discuss. Okay. First of all, everyone try, then I will discuss. Okay. Okay. First of all, try everyone, then I will discuss. Okay. Now, how can do? Visibility is clear. Visibility is clear. So, how can do this type of problem? First of all, see very carefully. According to if you apply nodal analysis, basically first one, what about first case? First of all, decide branch current. Okay, that one branch, that one branch, that one branch, that one, and this branch current already given. So, if you consider I1, here I2, here I3, here I4, and here I0. After that, second step, node voltage. Decide node voltage. Okay, here V1, here V3, and here V4. Okay, after that, take a reference node. Okay, if this one take a reference node, it means, what is the meaning of that one? These two are 0 0. Okay, after that apply KCL at node 1 V1 and V2. If you apply KCL at V1 node, then incoming, no any incoming current, all current are going. So I1 plus I2 plus I3 is equal to 0. Okay. What about I1? I1 is written V1 minus that voltage 0. Current leave from negative terminal, so minus 9 divided by how much? 3 kilo ohm. Plus what about I2? I2 is written as V1 minus 0. V1 minus 0 divided by how much? 6. Okay. Plus V1 minus V2 divided by how much? 2 kilo ohm is equal to 0. Okay. Clear or not? If anyone faced doubt, then tell me. I will discuss again. Okay. Now that one, take LCM. That one is written. That one basically written. If multiply by 6 in both side, then we got 2 into V1 minus 9 plus V1 3 V1 minus V2, this is equal to 0. So 2 V1 minus 18 plus 3 plus 1, that is 4 V1 minus 3 V2, this is equal to 0. So 6 V1 minus 3 V2, this is equal to 18. Okay, now if divided by 3, then we got how much? That is 2 V1 and that is V2 and that one is 6. That is equation number 1. If anyone faced doubt in any step, then tell me, I will discuss again. If anyone faced doubt in any step, then tell me, I will discuss again. Okay. If anyone faced out corresponding to any step, then tell me, I will discuss again. If okay, then comment it, sir, I feel okay. Okay. Now, after that, so first of all, make it. Okay. Now, this one remove, this one remove. Okay. Now, what about I3? I3 this will equal to I4 plus I0. What about I3? V1 minus V2 divided by how much? 2 kilo ohm. This will equal to I4 is written V2 minus 0 divided by how much? 2 kilo ohm, and I0 is written as V2 minus 0 divided by 2 kilo ohm. Clear? So V1 minus V2, this will equal to V2 plus V2. So V1 this will equal to 3 times V2. Okay. Now that value put here, then we got how much? 6 V2 minus V2, this will equal to 6. So 5 V2, basically V2 this will equal to 6 by 5. Okay. Recheck again. V1 minus V2, I3 is equal to I4 plus I0. Okay. So if that value put here, our motto determine I0. So I0 is V2 put here 6 by 5. 6 by 5 divided by 2. Then we got how much? 0.6 milliampere is the right answer. If anyone faced out in any step, then tell me, I will discuss again. If anyone faced out corresponding to any step, then tell me, I will discuss again. Make it. Okay. If you face any doubt corresponding to any step, then tell me, I will discuss again. Okay. Hello. So first of all, make it. If anyone face doubt corresponding to any step, then tell me. Comment it. Sir, I feel okay. Okay? Without any hesitation. Without any hesitation. Okay? Without any hesitation. Tell me, sir, please discuss again. Otherwise, I will move on. Okay? So I0 is 0 plus 0.6 milliampere is the right answer. 0.6 milliampere is the right answer. Okay? That question is okay. Now, after that, we have take another problem. Okay? Now, next problem is, so it's okay. We have taken another problem. That one is, sorry. Suppose that source voltage, here resistance connected, and that one a simple resistance connected, another resistance connected, and here voltage source, another voltage source like that one. Okay? Here minus, here plus. Here minus, here plus, that is 6 volt, that is 6 kilo ohm, and that one is 4 kilo ohm. Okay, after that a voltage source again, that one is 6 kilo ohm, and that one is plus minus how much? We have taken 24 volt. And what about current in this branch? That is I naught. Okay, according to question say, our motto determine source I naught with the help of nodal analysis. Using nodal analysis. Okay, determine I naught with the help of nodal analysis. If anyone faced doubt in any step, then tell me. So I faced doubt corresponding to that step. I will discuss again. I hope so. So first of all solve. Then I will solve. Okay. First of solve. Everyone try. After that I will try. Okay. After that I will try. First of all everyone try. Then I will try. Okay. Now, simple. First of I know that what about according to nodal analysis say, first of all decide branch current. What about branch current? You have taken another color. This one branch current already given I naught, and here we have considered I1 and here consider I2. After that, node voltage. How many nodes? That one and that one. So this one is considered V1 and that one considered V2. So first of all, that one remove. Okay. Third step, one node consider as a reference node. One node consider as a reference node. Reference node means that is 0 voltage. That one is means V2 is equal to 0 voltage. Okay. V2 is equal to 0 voltage. After that apply KCL. After that apply KCL. Apply KCL at node V1. One node here. No any incoming current or current are going outgoing. This one, this one, this one. According to node, apply KCL. Apply KCL at node V1. What about KCL? KCL say sum of incoming current is equal to sum of outgoing current. Sum of incoming current at that node is how much? 0. Outgoing current I1, I2 and I0. So you can say that here I1 plus I2 plus I0 this is equal to 0. I1 is basically, how can determine I1? What about current? V1 minus V2 or whatever. If any doubt, then we have consider simply this are V1 resistance and that polarity minus plus. Suppose that is E1. Here R1 and that is V1 and here V2. Okay, cut from the circuit that path and current direction here given I1. So sometimes student confuse, sir, I1 is written V1 minus V2 minus E1 divided by R1 or E1 is equal to V1 minus V2 plus E1 divided R1. Which one is correct? So how can verify which one is correct? Now, first of all, what is the meaning of that one? Basically, if here minus here plus that one E1, this one V1 and that is V2. Basically, if any circuit represent like that one, basically what is the meaning of that one? Basically that one represent this one with respect to ground. Okay, current direction going here, so plus, here minus. Now apply KVL in this loop, simple. If you apply KVL in this loop, minus 2 plus minus V1, okay, plus 2 minus here R1, so plus I1 into R1 minus E1 plus V2, this will be equal to 0. So what about I1? I1 is V1 minus V2 plus E1 divided by R1. Okay. So how can we memorize that formula? Simply, you can say that this formula is, if how can memorize? Simply V1 to V2. This is final minus initial voltage. Final minus, sorry, this one that is initial and that is final. So initial minus final voltage, initial minus initial, and that one is final. So initial minus final voltage. Okay. And if voltage source, if any voltage source available in the circuit, then current leave from, if positive terminal, then that one is positive. That one is positive. If that terminal is negative, then written here negative. Divided by this branch resistance, total that branch resistance. If R1, then R1. If R2, then R2. If R3, then R3. If R1 plus R2 plus R3, then R1 plus R2 plus. Suppose that number of more resistance than connected in series. So R1, though written is R1 plus R2 plus R3, whatever with the resistance. Okay, clear or not? If anyone faced out corresponding to how can what is approach, what about current? So clear or not? If current path is current is given like that one, then what about current written? Simply initial voltage minus final voltage. Current leave from, if voltage source connected in the circuit, then current if leave from positive terminal, so written positive that voltage. If current leave from negative terminal, so that is written negative. Clear or not? Clear or not? How can I apply that formula here? Simply, if anyone phased out, then tell me, I will explain again that concept. If anyone phased out, sir, I phased out, for that step, I will explain again. Okay, I will explain, repeat. Now, sometimes students say, sir, I have faced problem. What is the problem? Suppose that current is given. Current I1 is written V1 minus 0 plus 6 volt or minus 6 volt. How can decide? We have no idea. So first of all, take that branch, make represent like that one. Here V1, here V2, and this one represent, suppose that a generalized wave E1, and that is R1. After that, what is the meaning of that one? This one basically represent like that one. Here V1 with ground V1, and with, if written simple V2 means positive V2 with respect to ground, that is V2. And here E1, here R1, current polarity decided, that is positive, here negative. So after that, apply KVL in this loop. Minus to plus, that sign minus. Plus to minus, I1 into R1, so plus minus I1 into R1. Minus to plus E1. Plus to minus V2, this is equal to 0. So what about I1? I1 basically V1 minus V2 plus E1 divided by R1. Okay. So how can memorize that one? How can memorize that I1? Simply initial voltage minus final voltage. Current leave from positive terminal, so positive E1. If current leave from negative terminal, so negative. Divide by whatever be the resistance in that branch, simply written. Okay. If suppose the two resistance, then R1 plus R2. If one resistance, simple R1. Clear or not? If anyone faced out, it's, if you feel okay, sir, my all doubt are clear corresponding to that, then I will. Okay. I hope so. Clear? What about current? So apply here. Okay. So this one remove and written here. I1 is V1 minus 0. Here V1 minus V2. V2 is 0. So I1 basically we got how much? I V1 minus 0. Currently from positive terminal, so plus 6 divided by how much resistance? That is 6. Clear or not? Okay. And what about I2? If anyone say what about I2? I2 is V1 minus 0. No any source connected. So no any source connected in between these two. So simply don't be right. Otherwise plus 0 or minus 0. Divide by how much resistance? That is 6. 6. Clear? If anyone face doubt, then tell me. So I can remove. Now, what about I3? Sorry, not I3. Here I0. Here I0. I0 is written as V1 minus current leave minus 0. Current leave from negative terminal, so minus 24 divided by how much? 4 kilo ohm. That is 4 kilo ohm. So V1 minus 24 divided by how much? 4 ohm. Okay. Now apply KCL at that node. So I1 plus I2 plus I3 this is equal to how much? 0. Now that value, sorry, I0 this is equal to 0. So put this value. V1 is how much? V1 plus I1 is written as V1 plus 6 divided by 6. And what about I2? I2 is V1 by 6. And what about I0? I0 is V1 minus 24 divided by 4. This is equal to 0. Okay. Now, what about that value? If solving these two, then we got 2V1 plus 6 divided by 6. And that one is V1 minus 24 divided by 4 is equal to 0. After that, take LCM. If multiply by 4 here, 4 into 2, that is 8. 8V1 plus 24 plus 6V1, this is equal to 24 into 6. Clear? Now, 8 plus 6, that is how much? 14. 14V1, this is equal to 24 into 6 minus 24, that is 25. 24 into 5. Okay. So what about V1? V1 is basically 24 means 12 into 5 divided by how much? 7. Okay. Now 60 divided by 7 volt. That is V1. But what is our motto? Our motto determine I0. So that value put here 60 by 7. 60 by 7 minus 24 divided by 4. Okay. What about that value? With the with the help of calculator you can solve. With the help of calculator you can solve. Okay. Then we got I0. Then we got I0. Where my Kalsi?
जल्दी खत्म करिएगा.
That one is 60 divided by 7. That is how much? 8 point. That one basically 8.57 minus 24 divided by 4. And how much? Minus 24 divided by 4. So that is minus 3.8. minus 3.86 milliampere is the right answer. Make it. Okay. If anyone faced doubt at any line, then comment it any step, then comment it as sir, that step I faced the doubt. Please explain. Then I will explain, okay? If anyone faced doubt in any step, then tell me. I will explain again. Thank you, thank you, thank you, Mustafa, for appreciating my work. Thank you very much. If any doubt and any step, then tell me. Your valuable feedback is very important for me. So the final answer is minus 3.86. Final answer is minus 3.86. I hope so. It is clear. So now next problem is, I have taken another problem. Make it first of all, then I will take another problem. Okay. Now next problem. That is how much? 6 kilo ohm. And that one is also 6 kilo ohm. And that one is 12 kilo ohm. And that one is plus minus 12 volt. And here plus minus 6 volt. Okay. Our motto determine plus minus V naught. Okay. Basically our motto determine here V naught, and that one is plus, here minus given. Polarity already given. Okay. Polarity already given. Okay. So okay, 6 kilo ohm, 6 kilo ohm, 12 kilo ohm, that is plus minus 6 volt and plus minus 12 volt. So what about V naught? What about V naught? What about V naught? Okay. What about V naught? Simply determine V naught, okay, with the help of using nodal analysis. Using nodal analysis. Okay. If anyone face thank you. If anyone faced doubt, then tell me, sir, I face the doubt corresponding to that. Okay. If you understand, then tell me, sir, I will understand about your concept and whatever. Okay, so how can we determine V naught? Simply given that terminal positive and here negative in question. So first of all, solve. After that, write the question, write the answer in comment. After that, I will solve. Okay. After that, I will solve. Okay, first of all, try everyone. Okay, simply with the using nodal analysis. So if you use nodal analysis, basically, first of all, nodal analysis say decide branch current. So we have considered here I1, here I2, and here I3. After that, next step, after that, node voltage. How many nodes here? One, and here two. So this is V1 and that is V2. And after that, third step, one node voltage can take reference node. Reference node means zero voltages. Okay, zero voltages. So that one taken zero voltages. Okay. After that, apply KCL. Apply KCL at given node. At given node. So apply KCL at node V1. I know that what about KCL? If you apply KCL means incoming current, sum of incoming current, this is equal to sum of outgoing current. Sum of incoming current, this is equal to sum of outgoing current at that node. Okay. No any incoming current, all current are outgoing. So sum of outgoing current I1 plus I2 plus I3, this is equal to no incoming current means 0, this is equal to I1 plus I2 plus I3. So you can see that I1 plus I2 plus I3, this is equal to 0. I1 basically written V1 minus that one is 0. Current leave from negative terminal, so minus 12 divided by how much? 6 plus I2 is V1 minus 0. V1 minus 0 divided by how much? 6 plus I3 is V1 minus 0 minus 6 divided by how much? 12. This is equal to 0. Okay. After that, take LCM. Then we got 12. That one is 2 times V1 minus 24 plus 2 times V2. Sorry, that is also V1 plus V1 minus 6 is equal to 0. So 2V1 plus 2 plus 1, that is 5V1. 5V1 minus 30, this is equal to 0. So V1 is how much? 6 volt. So V1 is how much? 6 volt. Clear or not? If anyone faced doubt, then tell me, sir, I faced doubt corresponding to that. Then I will explain again. Okay. Now, next target is what about V0? What about V0? V0 basically, V0 is written as 12 into I3. So 12 into I3 is how much? V1 minus 6. V1 minus 6 divided by 12. And what about V1? That is 6 minus 6. Okay, that one cancel. So that is 1. So that is 0. It means basically V0 is 0 volt. Clear or not? If anyone faced out in any step, then tell me. So I faced out corresponding to that step. After that I will explain again. If anyone faced out in any step, then tell me. I will explain again. Okay. So first of all, make it. First of all, make it. Okay. First of all, make it. If anyone faced out corresponding to any step, then tell me, sir, I faced out at that step. Then I will explain again. Then I will explain again. Okay. If anyone faced doubt corresponding to any step, so I will explain again. Simply, how can do our motto? Determine V naught. So if you determine V naught, basically, if you apply with the help of nodal analysis say first of all decide branch current. If given circuit like that one, then first of all decide branch current. Here I1, here I2, and here I3. I1, I2, I3. And after that, decide node. That one, that is V1 and that is V2. Okay. Node voltage, decide. Third step, say one node volt is considered as a reference node. That's why V2 is considered as a reference node, that is 0. Okay. After that, fourth step, say apply KCL at node voltage. If at that node apply KCL, incoming current, no incoming current. So according to KCL, say sum of incoming current this equal to sum of outgoing current. Sum of incoming, no in incoming, all current are outgoing. So here written I1 plus I2 plus I3 is equal to 0. After that, what about I1? I1 basically V1 minus 0. Final minus initial. If current leave from minus terminal minus 12, so it is minus. Divide by that resistance. Plus, what about I2? V1 minus 0 divided by how much? 6. And what about I3? I3 is V1 minus 0. Current leave from negative terminal. So divide by total resistance on this branch. That is how much? 12. So 12 is equal to 0. After this simple mathematics, take LCM. Okay, that is 12. So if multiply 2, then 2V1, here 24, here 2V1, that is V1 plus minus 6, this is equal to 0, divided by 12. After solving, we got V1 this like that one. Our motto we determine V naught. V naught is equal to current in positive to negative. So V that is 12 into I3. So 12 into I3. I3 is basically V1 minus 6 divided by 12. V1 is already given 6. I have after solve we got 6 volt. That value put here, then we got 0 volt. So V potential difference, well, V naught is 0. So V naught basically 0. Okay. If anyone faced doubt, then tell me, sir, I will explain again. Then I will explain again. Okay. If anyone faced doubt corresponding to that problem, then tell me, sir, please explain again. Then I will explain again. Okay. Then I will explain again. Okay. If anyone faced doubt, so I will explain. I think, are you satisfied my all I've heard? Okay. So I will take another problem. I will take another problem. Okay. Okay. So I have taken another problem also. Now take another problem. That one is voltage source plus minus. Okay. And that one is 6 kilo ohm resistance connected here. And that one is plus 2 resistance. This one is 2 kilo ohm and that one is 4 kilo ohm given. Okay, and here given current source represent like how much? That is 8 milliampere. Okay, and here again polarity change, here minus, here plus, that is 12 volt. Our motto, determine plus minus V naught. Our motto, determine plus minus V naught. So according to question say, determine V naught with the help of using nodal analysis. Nodal analysis. Okay, first of all everyone try. First of all everyone try. Okay, after that I will do. After that I will do. Okay, after that I will do. So everyone try. Everyone try. Okay. If you not understand, then tell me, sir, I will not understand about that point. But please explain. Okay. So first of all, according to nodal, if you apply nodal analysis, so nodal analysis say branch current here I1, beside branch current here I2, and that current already given in this branch. After that, node voltage here Vx, and after that, and that one is 0 voltage. And if you suppose that that point is A, okay, A. So what about that point voltage? VA is equal to V naught or other. If any doubt, then you can make here, that is R1, and here VA and here VB is generalized way. What is the meaning of that one? Plus minus, here plus minus, VA and here VB. Okay, and that one given simply V naught. So apply KVL in this loop, then we got minus VA plus V naught plus VB is equal to 0. So V naught is written as VA minus VB. Okay. So what about VB? If you compare that one, what about VB? VB is 0. So basically VA is equal to V naught. Okay. If you retain that point VA, so that is VA voltage. VA basically V naught. Okay. VA is equal to how much? That is V naught. Okay. So how can we determine V naught? Our motto, determine V naught. So first of all, you can remove, apply KCL at that node. Incoming current, no incoming current, all current are outgoing. I1 plus I2 plus 8 is equal to 0. I1 is written basically Vx minus 0. Vx minus 0. Current leave from positive terminal, so 12 divided by 6. What about I2? I2 written Vx minus 0 divided by how much? 2 plus 4, that is 6. Okay, and plus 8, this is equal to 0. So Vx plus 12, Vx, so 2 Vx, this is equal to minus 48 minus 12, that is minus 60. So Vx this will be equal to how much? That is 60 by 2, that is minus 30. Minus 30 volt. Clear or not? Vx is how much? Minus 30 volt. If anyone faced doubt, then tell me that I faced doubt corresponding to that step, then I will explain again. Okay, now what about I2? I2 is Vx minus V0. I2 basically written, someone written Vx minus V0 divided by how much? 2 kilo ohm. Another word, another person say Vx minus 0 divided by 6. Okay, Vx minus 0 divided by how much? 2 plus 4, that is 6. Our motto, determine V0. So after that, solve this one. So 6 basically 3 into Vx minus 3 V0 is equal to Vx. So we got Vx is how much? Vx is we got minus 3 by 2, that is minus 1.5 into V0. So what about V0? V0 is equal to Vx is minus 30, so minus minus plus 30 divided by 1.5. So that is 300 divided by 15. Okay, and that value after solving, what about V0 finally? 20 volt. 20 volt is the right answer. Okay, if anyone faced doubt, then tell me, I will explain again. If anyone faced doubt corresponding to that question, then tell me. Thank you, nice, thank you. How can? I will explain again. Now apply I1 plus I2 plus 8 is equal to 0 at that node. No any incoming currents, all current or outgoing. So that's why I written like that one. After that, I1 is Vx minus 0 currently from positive terminal, so plus 12 divided by 6. What about I2? I2 is Vx minus 0 divided by how much? 2 plus 4, that is 6, and that is 8. This is equal to 0. After take LCM, then Vx plus 12, here Vx, and 6 into 8, 48, this is equal to 0. These two, Vx and Vx, that 2 Vx and 12 plus, that is minus 60. So what about Vx? Vx is how much? Minus 30, 60 by 2, that is how much? Minus 30 volt. Okay, Vx is minus 30 volt. After that, what about I2? I2 written Vx minus V0 divided by 2. Other word you can say the Vx minus 0 divided by 6. Okay. Now, if take, how can solve these two? Multiply by 6, 6 by 2, that is 3. So 3 into Vx minus 3 V0 is equal to Vx. After that, if this one is going on that direction, okay, if this one is simple, if Vx is come to here, then 3 minus 1, that is 2 Vx. 2 Vx is equal to plus 3 V0. That is plus 3 V0. Okay. 2 Vx, this is equal to 3 V0. So 3 by 2, that is 1.5 V0. Okay. Clear? and after that Vx is also minus 30, so put here minus 30, so minus 30, so we got minus 20. So final answer is minus 20. Okay, make it. So silly mistake here, that is minus. Okay, I hope so. I hope so. Okay. If anyone faced out, then tell me, I will explain again. If anyone faced out corresponding to that question or any question, tell me, I will explain again. Okay. Anyone faced out, then tell me. I will, otherwise, I will. Okay. So this one is the last problem. Tomorrow I will discuss again on the basis of nodal analysis, based on some other problem. Okay. If anyone faced out, then tell me. I will explain again. So tomorrow I will take another problem. Okay. Some other problem also on the basis of nodal analysis. Okay. Thank you very much for joining the class. Okay. At the same time,